When we have a lot of users at two different sites, it makes sense to not do individual remote access VPNs, but instead to implement a site-to-site VPN between those two local area networks. And that, my friend, is what we're going to do in this nugget. One of the beauties about virtual private networks is that we can build a logical tunnel or network between 2 points and then secure that. We can have authentication to make sure we have the right endpoints for that VPN tunnel, and we can encrypt and verify data integrity for those packets going back and forth. So for this lab, I've changed the topology just a little bit. I've got two sites. We have site 1 over here on the left and site 2 over here on the right. To make it really fun and easy to remember where stuff is, over on the left, we've got the 10.11 network at site 1. Over on the right, at site 2, we have the 10.22 network. And then we have two VPN gateways that are going to be used to build a site-to-site VPN tunnel across another network. So this puffy cloud here could be the internet if these two servers had connectivity to each other over the internet. And in our lab environment, I'm just using our 192.168.1 network as the replica of the internet that we're going to be using to build the VPN tunnel across. So for this example, it's just a transportation medium to get packets back and forth between DCNUG and server 2, which are acting as the two endpoints for our VPN tunnel. Now, the ultimate goal here is that when the client at site 1 needs to access resources at site 2, the traffic would be forwarded over to DCNUG, who would identify that as traffic that needed to be encrypted and tunneled and shipped over to its VPN peer, server 2, who would then decrypt that data and then forward the packets naked onto its final destination. And then for the return path, it would be very similar. The replies from the server would go naked over to server 2, who would then identify based on routing, this needs to be encrypted and sent over to my good buddy DCNUG, who then decrypts it and forwards the response. And the goal is the VPN, as it crosses this cloud, this network between the two VPN gateways, is protected and encrypted. And in preparation for this lab and for this nugget, I've done a couple of things. Number one, I removed and installed the routing and remote access service on both DCNUG and server 2. So they're in their brand new configuration regarding routing and remote access, as if we just installed those roles. And as part of the configuration, we're going to create some on-demand interfaces. And an on-demand interface, the concept was like 20 years ago, back in our dial-up days, is that if we had a connection that wasn't always persistent, if there was traffic that needed to go over that interface, it would build the connection on demand. So with our VPN tunnels, we can have them on demand, or we can also have them persistent. And also, as part of building that tunnel, the two peers need to verify each other. So we'll create some user accounts. And for this lab, let's create a user account called VPN_2_site1, and another user account called VPN_2_site2. And I should put those in the other direction. Let me put site 2 over here and site 1 over here. When we create the on-demand interface here on DCNUG, what we're going to do is we're going to name it VPN to site 2. And on server 2, when we create the on-demand interface here, we're going to name it VPN to site 1. And that way, when they talk to each other, they're going to use those interface names as part of the authentication to allow the VPN tunnel to come up. So not only will we want to create these two user accounts in Active Directory, but we also need to make sure that through either network policy or through their individual accounts, that they are allowed to go ahead and connect to an access server. And we can do that either on the individual account for those two by clicking the checkbox saying allow, or we can do it through network policies. Because if those accounts either directly or through a network policy don't have the ability to connect to a server, then when the two sides try to initiate and build the tunnel, it's going to fail. And one other piece that we also need to do that's quite important here is we need to set up routing. So DCNUG and server 2 both are on the 192.168.1 network. It's representing our cloud here. DCNUG is at .100, server 2 is at .102. And when we build the on-demand interfaces as part of the VPN, so they can build and establish the tunnel, we also need to set up routing. So in our configuration for DCNUG, we're going to have a little conversation that goes something like this. Dear Mr. DCNUG, if you ever need to reach the 10.2.2 network, the way to get there is to go ahead and use the tunnel interface, the on-demand tunnel interface that we created that points over to server 2. And we also need to tell server 2, Dear Mr. Server 2, if you ever need to reach the 10.1.1 network, from a routing perspective, go ahead and use your tunnel interface, which would also then trigger the encapsulation and forwarding of that traffic over to your good VPN peer DCNUG, who would then de-encrypt the traffic and forward it on to its final destination. And so without the routing in place, the VPN traffic won't flow. It has to have a reason for going through the VPN tunnel. And by having that routing information configured on both of these servers, it'll allow the VPN to go ahead and be used. So now that we've talked about like the concepts of how it works, let me walk you through it step by step. And then when we're done, we'll verify it works. And then you can practice this hands-on in the hands-on lab. So let's begin our configuration from left to right. We'll start with DC-NUG, who's connected to the 10.1.1 network on the left, and the 192.168.1 network on the right, which is representing our cloud between DC-NUG and Server 2. So here on DC-NUG, let's go ahead and open up Server Manager. So we have a little message here indicating that we've recently installed the role of Remote Access Server. And we can go ahead and click here to open the Getting Started wizard, but we're just going to go directly to Routing and Remote Access and configure it from there. So to do that, we'll click on Tools, and we'll scroll down on the list, and we'll select Routing and Remote Access. We'll bring that full screen, and then we'll right-click on DC-NUG and select Configure and Enable Routing and Remote Access. So we have the Setup wizard. We'll click on Next. We want to do a secure connection between two private networks, aka a site-to-site VPN. And with that selected, we'll click on Next. Next, it's asking, do you want to use demand dial connections to access remote networks? Now, we're going to say yes. If we say yes now, after we finish this wizard, it'll pop us into the wizard for creating a demand dial connection. So we'll go ahead and click on Next to continue. As far as IP address assignment, we'll specify automatically. And then we'll click on Finish. Now this process here takes a couple minutes, which is okay. We'll go ahead and let it continue. And now it's popped us into the Demand Dial Interface wizard to create our on-demand connections. So we'll click on Next to continue. And this right here, the interface name, is the logical interface for our tunnel on DC-NUG. So here we're going to name this VPN_2_site_2, which we'll also need to create that user account in Active Directory. And then when we configure Server 2, the interface we'll use there is VPN_2_site1, just the reciprocal of what we're doing here. We'll click on Next to continue. The radio button for connect using virtual private networking is selected, so that's great. We'll click on Next, and then we'll go ahead and let it automatically select the VPN type. And then later, if we wanted to tweak that, we could add additional information. For example, pre-shared keys that could be used as part of IKE and IPsec, or we could use certificates and different authentication methods. For now, we're going to let it go ahead and do automatic selection, and we'll click on Next. Next, it's asking, okay, who's your buddy? Who are you going to connect to? And DC-NUG is going to build this VPN tunnel over to Server 2 at the IP address of 192.168.1.102. So we'll put that IP address, which is the reachable IP address of Server 2, across the cloud, and we'll click on Next. And now it's asking, hey, do you want to route packets on this interface? And yes, we do. So we'll go ahead and click on Next. And here it gives us an opportunity to add a static route. And here's how it goes. In fact, let me click on Add, and let me walk you through how it goes. We're simply going to put in the remote network of 10.2.2.0 with a 24-bit mask, just like that. And let's give it a metric of 100. If you had multiple possible paths, the metric would be more important. But because we're only going to have one path to get to the 10.2.2 network, the value of 3 or 100 or 250 is not going to make a difference. And then we'll click on OK. And there's our route that's going to be associated, or should be associated, with this tunnel interface that we're creating, this demand interface. So we'll click on Next to continue. So now it's asking for the dial-out credentials. What username should we be using for the authentication? So I've got a question for you. On the interface that we are going to configure over on Server 2, what are we going to name that? And if you recall, we're going to call it VPN_2_site1. So for the authentication name that we're going to put here, we're going to put in that username. So we're calling this VPN_2_site1. And that way, when DC-NUG initiates the VPN tunnel over to Server 2, this username matches exactly the tunnel interface name over on Server 2, and it'll use that as part of the authentication. And the question might come up, well, what if we just use one user account for the authentication on both sides? For example, we called the interfaces Bubba, and we had a username called Bubba. Would that work? And the answer is yes, that would work. But if you look at the configurations, it might not be too clear about which tunnel interface goes where if it's just called Bubba. So for the domain, we'll go ahead and put Nugget Lab. And for the password, we'll put our lab password in, and we'll confirm our lab password. And with those in place, we'll click on Next. And then we'll click on Finish. And it says it's done. Now, even though it says it's done, it didn't It's not my fault. Don't shoot the messenger. It didn't actually create the static route for us. It would have been great. I mean, we put all the information in. We said, hey, to get to 10.2.2, use this demand interface. But it didn't actually add the static route. If we go to IPv4, click on static routes, wah, 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 wah. So we need to add that static route. Now, it's fairly easy to do. You simply right-click here, or you could right-click on static route. Either way, select New Static Route. And then we can go ahead and specify our interface. We're going to use our tunnel interface, the one called VPN_2_site2. And then we can put in the destination of 10.2.2.0 with a 24-bit mask. And because we specified a tunnel interface, there's no option to put a default gateway. This static route effectively says, hey, to get to 10.2.2, boom, just shoot it out that VPN logical tunnel interface. And because the tunnel interface knows who the peer is on the other side, it'll go ahead and send it across to the peer over the VPN tunnel. So if you want to change the metric to something lower than 256, you're welcome to. Again, it won't make a difference because we don't have a whole bunch of competition. We're getting different ways of getting to 10.2.2. There's only one path, and that's through this tunnel. So we'll click on OK, and now that's there. The other thing that we might want to do while we're right here on the domain controller is let's go ahead and create our 2 user accounts in Active Directory. So to do that, we'll click on Server Manager. We'll go to Tools. And from the list, we'll select Active Directory, Users and Computers. We'll bring that full screen. We'll drill down to nuggetlab.com, Users. And then we can use one of the icons on the menu bar or simply right-click here, specify New, and we'll create a new user. So we'll create our user called VPN to Site 1. And I'll paste that in as the logon name as well. Click on Next. I'm not going to make that user change their password because it's going to be pretty tough for it to do. It's not a human, it's a computer. So we'll also click on Password Never Expires, and then we'll put our lab password in and confirm it, and click on Next. There's a summary, and we'll click on Finish. And let's create one more user for VPN to Site 2. So we'll right-click, click on New, specify User, and we'll create the user VPN to Site 2. We'll do a Control-C to copy that and have that for the user logon name as well. And click on Next. And we won't make them change the password, and we'll say password never expires, and we'll supply our lab password. And we'll click on Next, and we'll click on Finish. Now, while we're here, we have a couple options. Number one, we could configure both these user accounts and specify that they are allowed to connect via dial-in as a remote access user. Or we could go to the network policy server, and we could make a global policy saying anyone's allowed to connect. And since we're right here, let's go ahead and give that access to these 2 users. So to do that, let's go ahead and double click on our Site 1 user and go to Dial In, and we can click the radio button for Allow Access. And the default was control access to the network policy server. And we've done that in a previous nugget when we did our remote access VPN. We actually went in and set that policy to allow as the default. And here in a moment, I'll show you where that is again in the event you want to do that globally instead of for each of the users. But the key here is we need to make sure at least one of those options is set to allow access for dial-in. So we'll go ahead and click on OK, and then we'll do the same thing for the Site 2 user. We'll click on the dial-in tab for that user and allow access and click on OK. Fantastic. So we'll go ahead and minimize that. And let's go back to our routing and remote access just for a moment, and let's verify our work. So we've got our network interfaces. Here's our VPN to Site 2 that we just configured. It's a demand dial interface. Currently disconnected for lots of reasons. One is the other side is not set up yet. And if we double click on that interface, or we could right click and go to properties of that interface, it has the peer that we're going to connect to, which is the IP address of server 2. Under options, it's a demand dial interface, but if we wanted to be persistent, we could check the persistent connection instead. And that way, if we always had connectivity, we could always have the tunnel up, as opposed to just building it when there's traffic that says, hey, we need to go over the tunnel. If we click on the security tab, the type of VPN is automatic, and for our demo, we'll leave that alone. And for authentication, it's going to have the options of using MS-CHAP version 2 or just CHAP. And if we wanted to specify EAP and use MS-CHAP here with EAP, we could do that as well. In fact, let's do that. As long as I remember to do it on both sides, we're good. So automatic VPN, require encryption, and using EAP with MS-CHAP. Fantastic. And then for networking, I'm going to deselect IPv6 for this lab, for this VPN. So it's just going to be a tunnel supporting IPv4. So then we'll click on OK. And now let's go ahead and configure server 2. And server 2 will be a little bit faster because we already have the user account created. And it's basically a repetition of the same steps, but pointed in the other direction over to DC-nug. So here on server 2, we'll go ahead and launch Server Manager. We have a little message indicating that The service was recently installed, and we could go ahead and run the wizard. However, just like we did for DCNUG, we're just going to do it directly through the routing and remote access tool. So we'll click on Tool, scroll down, select Routing and Remote Access from that drop-down. Right-click on Server 2, and select Configure and Enable Routing and Remote Access. We'll click Next for the wizard. We'll specify that we want a private site-to-site VPN tunnel created using the second from the bottom option here. Clicking on Next. Yes, we want to do demand dial connections to remote networks. Click on Next. We'll do the IP address assignment automatically and click on Finish. And it says Windows was unable to add this computer to the list of valid remote access servers in Active Directory. You may want to have an admin fix that. Okay, so we'll make a note and we will fix that. We'll click on OK to continue. And now that's done, it's going to bring us to the demand dial interface wizard. We'll click on Next. And here we're going to call this interface VPN to Site 1. So we'll click on Next to continue. The VPN option is selected. We'll click on Next. We'll let it automatically select the type of VPN. Click on Next. It wants the IP address of the peer. That peer is going to be 192.168.1.100, which is DCNUG's IP address across the cloud. Clicking on Next. We want to route packets on this interface. Click on Next. We're not going to bother adding the static route because for whatever reason it doesn't put it in the static route table. So we'll just manually add it after, and we'll save the time here. And we'll click on Next. And now we're going to put the credentials that match the dial-in credentials configured on the remote router. Effectively, we're matching the interface name of the other side of the VPN. So that username is going to be VPN_2_site_2 because that's the interface name for the tunnel on the other side. That's in the Nugget Lab domain. And then I've supplied our password and I've confirmed it, and we'll click on Next to continue. Then we'll click on Finish. And what we need to do here is a couple things. Number one, we need to make sure we have that static route. So we'll go under IPv4, Static Routes, right-click, New Static Route. And the interface we're going to associate this route with is VPN to Site 1. The destination network is the one on the left, 10.1.1.0, with a 24-bit mask. And for the metric, it won't matter too much what that metric is because there's no competition from Server 2's perspective because there's no other routes it's aware of how to get to 10.11 except through this VPN tunnel interface. So we'll go ahead and click on OK. And the two user accounts, we already gave them access to go ahead and do dial-in. And if we wanted to do it globally, just let me remind you where that would be from Network Policy Server. We could click on Remote Access Logging and Policies, emphasis on the policies, right-click on that, specify Launch NPS, give that a moment to come up. And under Network Policies, we would go ahead and specify right here that we want to allow connections to Microsoft Routing and Remote Access Server. So if that was not enabled, you could double-click on it and then click on Grant Access and save that. And that also, by default, would allow the remote access, which would allow the VPN tunnel to establish between the two peers. All right, so let's close the Network Policy Server and let's go back to Network Interfaces and look at this. So it's connected. VPN to Site 1, it says it's connected, and I wonder if it is. Now for the testing angle, let's do this. I have client NUG that has actually two interfaces. It's got one connected to the 10.1.1 network, and it's got another one that's connected to the 192.168.1 network. So what we'll do is we'll go to client NUG, we'll just simply disable this interface, take it out of the picture completely, and then it has a default gateway of .100. So when the client goes for any resource, no matter what it is, once we disable this interface, he's sending that traffic to DCNUG. And if the traffic is destined to the web server at 10.2.2.2, because DCNUG has the demand interface, its end of the VPN tunnel, and it believes that to reach the 10.2.2 network, it should forward traffic over that tunnel, the traffic from the user should go to DCNUG, be encrypted, sent over the VPN tunnel, encrypted. Server 2 should then de-encapsulate that and forward the packet onto our server at 10.2.2.2. At which point, when the server responds, it'll follow that reverse process on the way back. So here on our client, let's go ahead and modify our network connections just a little bit. We'll right-click on the Windows icon, bottom left-hand corner, select Network Connections, give that a moment to come up, and then we'll go ahead and right-click on Inside 192, disable that interface, and then we'll click on Site 1 interface, right-click on that, and enable it. And then also, just to verify that we're on the same sheet of music and that it's actually working like we think it is, let's also bring up the integrated scripting environment using the icon on the taskbar. Let me do a CD to get us a little more room there. And let's do a couple things. Let's do a get-net IP configuration and hit F8 just to verify what our addresses are. And that reveals that our IP address is 10.1.1.120. Good, so we're on that network on the far left at site 1. And our default gateway is .100, which is DC-NUG. And we have no other IPv4 routable addresses that are currently active, which is what I wanted to verify as well. So next, let's go ahead and do a test-net connection. And let's go out to 10.2.2.2. Now, I always get a little excited, nervous, anxious the first time I bring up a VPN tunnel to verify it works, and I'm just cross my fingers that it does. So with the cursor at the end of row number 2, let's hit F8. Oh my gosh, that's awesome. There's a lot of stuff that could go wrong. For example, if we didn't allow remote access, if we didn't put the static routes in, if we didn't have the user accounts created in Active Directory, if we had the wrong authentication credentials on both sides of the VPN, any one of those would have tipped the scales out of our favor. So this says that we were able to connect to 10.2.2.2. We used our Site 1 interface to do it. That's this guy right here. And it was successful. And the delay was 4 milliseconds, which is a little higher in our lab environment than what it would normally be. But the reason it took a few extra milliseconds is because it had to go through the VPN tunnel. And that does take a little effort. Also, to verify that, what we could do is we could bring up a browser, because that web server at 10.2.2.2 really is a web server. So if we put in 10.2.2.2 and press enter, there it is. This content brought to you by the recycled server. And I call it the recycled server because we've used it a few times in our nuggets previously. And so I just re-provision the IP address, re-provision its default route, and then it happily sits wherever we put it on the network. And then if we go back up to our server, either DC-NUG or server 2. And for this example, let's go to server 2 for a moment. And here on server 2, if we click on ports, and then let's sort in the status column just by clicking on that. Here we have an active port. It's PPTP, which implies that we built a PPTP tunnel between these two servers. And if we double click on that, or you could right click and go to status, either way, it'll give us the status, including the bytes in and bytes out. And if there are packet errors, they would show up here as well. So we'll click on close. And now, my friend, it is your turn. I would encourage you to practice this step by step. Just follow along with what we did together in the lab to get your own hands-on practice in building a site-to-site tunnel using Windows 2016 servers. And when you're done, I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.